Yeah, I want to tell today about my experience with earth construction and with the poor earth, uh, where, and in this case, special for rammed earth. I make also other earth construction, but now I will show you only the part of earth construction. And I want to start from what is earth or clay for the building. And the material what we use for rammed earth is every kind of eroded material from the site, from long million years ago or from 10,000 years ago, it doesn't matter. And the erosion material it forms the landscape, and on this erosion material, the wood, the plants are growing, and so these two material, the eroded material, clay, earth, and plants, wood, bamboo, or some other elements, are the real building material for future who is very sustainable. And this is also the building material we used about thousands of years, because was always local material. And we know everywhere in the world there are so much old earth construction in a big scale, because it was everywhere it was available. The Alhambra, or in Egypt, they have built so much, or in Syria, everywhere you can find big structure, and now why we don't build it again. And for me, if I have studied ceramic and work with earth, so the first, the real impact for me was that I have seen that earth construction is not only for the source and dry countries, that I saw that we have in Europe so many earth construction, and it was a real big tradition to build in rammed earth, in cob, with plaster, with bricks everywhere, because it was located on the site. And in history, you can find everywhere in Europe, you can find a big structure in earth construction. And you also in Portugal, you have so much earth construction, and also in Spain, and this in France, also in Italy. There is everywhere in Europe, earth construction was a very important building material. And also in Switzerland. In Switzerland, so many earth construction from the 19th century, if they are restored, they are wonderful buildings in a good structure, in a good design. And now, why we don't build it again? So we have to learn from the old structure, but to transform this in a new design, and to transform this with the modern earth construction, because we have forgot to develop not only the material and the technique of earth construction, we have also not learned to build, to find the right speech, architectural speech for earth construction. And this is for me very important. I said, if I want to make an earth construction, I want to see from outside that it is an earth construction, or if I go into the house, that I feel this building is built really with the local earth. And if we use the local earth, and it is and we separate it, we make separate it with a gravel sieve, make the foundation, build the house, and then it can go back. If this circle of preparation of the earth, construction, recycling, and excavation, if this circle is small, then it is really healthy and it's really sustainable. Earth construction is really the champion of earth construction. Exactly. After 25 years, I want to build my own house. I want, if I was co-planner, I was the client, and I was also the contractor. So I can really build much more consequent. And I want to build a house very consequent, 100% from the ground, and only work with the limit what I can find on the side. As there is the local wood from the side, 500 meters nearby, the earth from the excavation, and the construction is also 45 centimeter rammed earth, like a small Alhambra. So it's the same mood, and it can show that we can really work with earth in a very high quality solution if we use it in a technical part, also the handcraft work, nice surfaces, good corners and good details, and then the architectural design. And if we use everything from the side, so it is really sustainable and ecological. And there is the material life circle. If I don't know if you can see my mouse. Is it possible? No.
Yes, we can.
You can see, yeah. Here is there is the excavation, and you prepare the excavation. I will show you later. Then we can prepare it in a factory or on site, transport, production, building, and it goes back. This circle is very small. And if we have timber, so there is the wood, then is the processing, timber production, and at least the recycling. You can use something, but at least you have to fire it back. Also the brick life circle. There is only a line. It is no circle. You cannot bring it back to the earth. And also in the concrete life circle, it is only one line. And what is sustainable? Sustainable is always a circle. That and the earth construction is really very helpful for this. And so in all my experience, we are always look with if there is a big project everywhere, it doesn't matter. So we use always the local excavation. And example in Bordeaux, we are start now in Bordeaux, a big project with a field factory, and there is the result of this the excavation. You go there, you make the excavation, you look the material, and then you separate the material. Then you have different excavation material, and you can store it here in a old structure nearby. And this is also the space for the prefabricated factory, what we are still built there. And then we make samples, we make a recipe, we make a testing. And so in this kind, we make this procedure in several countries, and in every this project, you can see only this is the map of Europe, where we have used 100% the local material excavation, or we have used 90%, or we have used 75% in England. I believe, and I say always, from every excavation, you can use minimum 50% of the excavation local, and until 100%. Example, in my house, I used 100% from the local excavation. And so the earth is everywhere a little bit different. You have to go there, you have to make an analysis by hand, by testing, and there is always the same procedure, but you can mix it for art, on site. And what I want also discuss, if you know about earth construction, we know there is the real rammed earth structure without stabilization, and it is a pity that also stabilized earth construction is, for me, is not earth construction, it is a rammed concrete. So why we use rammed concrete and not earth construction? Because it is easier to add some material into the mix. And we believe if we add some cement or some lime or something else, chemical or something, so we are believe, and it is true that it is a stronger structure, but it is not necessary, this stronger structure. Because if you use rammed concrete, I name this dirty rammed concrete, and or you can say colored rammed concrete, but it can also be the material from the side, but you have to add maybe 6 to 10% cement. And if you have a thicker wall as normal concrete, I believe, and I think that if you make rammed earth stabilized construction, you need more cement as a normal cement as a concrete construction. So and it is very important that you can let the material natural, and like in the natural, like in the how's my English, natural, also like in the landscape, and it can erode it. And what we are using, we have used different excavations from different size, mix it together, like the winemaker puts different wine together to make a very good wine. So we use different excavation, and excavation, we separate it, and this is nothing else as prepared earth from the excavation. This is, and if you, what is very important in the material, that it is well preparated, that it is, it has the right water condition, about 9%, is mix it with a concrete mixer in a very good quality. So you have a real, the special earth, and it is nothing else as excavation material, well prepared. And for future, there we have so much excavation everywhere, and in Austria we have to deposit this and to pay a lot. For 1 ton excavation, we have to pay in the moment about 25 euro per ton. It is a lot. And if we can prepare it, so it is for free. And, and you can, this material, you can produce this by hand, only with rammers, like in history, or here in a project with Anna Herringer in Worms. There is a altar in the Basilica of Worms. This earth block is rammed all from these people and all by hand. That shows that you can build with earth construction, handmade, low-tech, in a very good quality. And this is a very interesting part of the earth construction. You can use the earth, the excavation earth, to build in low tech and low cost. You can build in low tech the same quality as you build it with very big machinery, with a big technical issue. You can ram this material by hand, or you can ram this material by rammers with pressure, fresh air. It is much more effective. And you here on the right side, you make cubes for testing, to testing, and here in the shattering to ram this very strong. But in if this project is very big and very big, and it is in a industrial country where the human work is very expensive, so I say we should let the material natural, but we have to develop the tools to find an easier way to build rammed earth construction. And so if I started for over 25 years to make project with prefabricated elements, because the prefabricated elements you can work more efficient, and you can work more in a dry condition, as in a factory or not on the site. So it is, and for that I had an idea a long time ago to make like a printer. There is the material, it comes out, here it's laying, and then you have a rammer here behind, and you make a long wall, open the shattering, then cut the elements, and so it is possible to work in a big amount of material, because the tool and the machinery is very helpful to save the very hard, strong work, because the strong work, it is it should be we should find the right tools, and so also the factory is a tool, or the working space that you can work more easily. But it is a lot of handcraft too also, but you have a lot of you can work such easier, and so you have here this also, if I have a thick wall, or you have so sorry, and then you open the shattering, then you cut the elements, and you can that's and so you can also lift it out, the elements, and this machinery, it is maybe this rammer are 6 people, because you can ram it extremely hard and it goes continually. So, and then you have these blocks. These blocks, cutted blocks, every block has identification. It is not a block like a brick, you make it and then sell it. So this block is very precise, produced only for this part of wall. Like here, if there is a house, the architect planned this house, then in our company, we make the blocks, this design, and the bigness of the block comes from the logistic situation, crane, transportation, windows, doors, etc. And then you bring this block to the side, you take this with the crane and lift this with clay plaster together. And so it is like Lego block, if you know Lego. It is so you can, and two layers are one storage, the one okay, is one part, and then yeah, so in one day you can set about 10 to 20 blocks, and it is really efficient. And then there mostly we use wood ceilings with a little bit concrete for the ring beam like this. And here you see you can make also like structures like this, walls, and in this case we have the earth construction is load buried, but inside and outside there is a reed isolation and lime plaster. Lime plaster in a very traditional using. You see here the earth construction, load buried, then the reed 16 centimeters and the lime plaster. So it's outside. This is it is an experiment house. It's the earth house for my daughter, and here you see my first atelier building. We have built it for 33 years, so for over 30 years. And this wall, this is a new picture. This wall is 30 years old. Also it is the weather side, and you see the brick layers, and it is very efficient against erosion. I come back to the in other slides for the calculated erosion. And inside we let the earth construction there, also visually there is no plastering, and you see here the joints of the elements. You can make these joints wet, and here you see also here to the window. You can make it very carefully with no joints, and it is load buried. And and for that we need a lot of research. We make a lot of research ourselves because I think for future it is very important that we make really load buried buildings with earth construction in a big amount. And for that, it is very important research and testing for the calculation, for the engineer, that they can be a responsibility that this structure is holding. We have also we are working together with Herzog Demaro with a wood construction, together wood construction and ceiling, the ceiling with rammed earth arches. You can see it here. We make a mock-up. We have make a fire resist, also fire. Yeah. That is against the fire. Was very good. You see here the wood construction. It is like this. This is ramped, wood construction ramped, and so on. And you see it from the under there. And I think this is also a future solution that you can here. You use less concrete for the foundation. Concrete is really a genial material, but we use it too much. So we have to reduce this amount of concrete. We have to build in earth, and in the ceiling, we can use other structure, maybe arches, or we can use timber as a wood, because for that it is very useful. And so and with the right tools, machinery, you can really build a big amount of building. We are more not a factory. We are a manufacturer in the moment. We use machinery, but it is also a lot of handcraft included. The tool, our working hall, also this Erdenwerkhalle in Schlinz. We have built it in the last 2 years for this machinery, Roberta. And you see, this is the wood construction, is load buried on the rammed earth wall. And on this side, it is a wood construction, and then it is and this massive rammed earth, here it is 12-meter high. We build it on site. You see here, it is a lot of work, but and here you see the corset, so you can really build very high walls inside with also some tools and like. Yeah, it is very effective, and here you see the Thor's wall, because this is so thick, because against the noise to the gardens from the neighbors. And on the other side, it is wood construction and with filled with brick with wood chips and clay together. So there is also a lot of experience. What I will show you now, some big projects, what we have realized in the last 20 years. There is a Riccolo Herbstcenter in Laufen with Herzog Demaro. It is a big factory, about 110 meter long, 30 meter wide, and 12 meter high. It is a concrete construction with beams, concrete beams, and outside there is a facade only built with earth construction, 45 centimeters. You can see the facade inside and outside, because it is a storage. And here, this 45 centimeter wall has also an impact of the climatization of the storage of the herbs in this building. So this massive earth construction helps to regulate the humid and the temperature inside. And what you see here is the Riccolo Kräuterzentrum, the buildings place. From here, we could find the argil or the clay. From here, the excavation. from here some gravel, what we need for the calculated erosion. And here we could rent a factory, and we have produced every elements here and transported 3 kilometers to the site, and then there we produced with 600 elements. And now I want to talk about the calculated erosion, because if we want to let the earth construction outside visually, it is necessary that we accept the calculated erosion. The calculated erosion means that the structure, the fine material, is going away from the water. And here you see some lime plaster layers. You fill it in the production. And here you see this lime plaster. And this is strong. And if this water is eroded, like here, the water is running down, this is not a roof, it is a speed breaker. Speed breaker means if the water flows slowly, so the erosion is not so strong. The idea is from the natural and also from old structures. You see, this is they had no chemical situations or like this, but they have also built in earth and with stones. It's also protection for rain, but it is also protection from sun. It is like a shadow, that's the wall doesn't heat up so much. And here is the wall in my studio. It is about 33 years old. You can also let plants growing over there. And erosion is no real problem, technical problem. It is only a psychological problem, because we don't accept, or we don't like to accept changing material on the house. We have to let the element change. It's the, so you can see in an earth house, where is the weather side and where is the sun side, or the source, or less weather. So you see here, this is the west side, here is the south side. On the south side, you have 0 erosion after 10 years. And on the west side, you have the erosion, and you see there is the erosion. Then here is the speed breaker, and here is the sedimentation of the clay particle. And yeah, and if the quality of this building, the quality of the mix, the quality of the ramming procedure and the shattering, if everything is done in a high quality, then it is really working. It's no problem. And that here you see in the herbs the big elements. And if you make the joints wet and ram in exactly the original material, you don't see the joints later if it is dry. And that's the earth is not waterproof. This is the best quality of this material, because if we would make this with stabilized earth, you cannot retouch these joints so very well. And in with this natural material, you can also retouch everything. You can make the connection with no joints very easily. It is so fantastic material in designing, in working, also for the hands, everything. I'm really, it's a pity that we don't build so much more with earth construction, because we have not learned, and it is important that we get more trust to this material, to this natural material. And this is also the most problem, that we have not enough trust to this weak material. Also, earth construction is, or rammed earth is about 10 times less strong as concrete. But it doesn't matter. You have to deal with this. You can build in a high quality big wall, like here. This is in Darmstadt. We had prefabricated 307 pieces. It is produced on site in a factory. You can, there is a facade, it's 12 meters high. And okay, I have no picture. There inside is a isolation. You can see it inside and outside. And yes, here it is also on the wetter side. You have a little bit more erosion. In the on the south side, here you have no erosion. Also this is a very natural material, and that is important. Or here is last year we make a 5-story high building in earth construction. This is only a facade. It is not load buried. It is a facade, 35 centimeters. You see here, you have here the brick layers. It is connected with the windows. And here you see the lime plaster. And here in the corner, we used a lot of lime plaster in every layer, because on the corner, the calculated erosion is the most, also is more, and so you use there more lime. And if we put away the structure, then the fixing point of the scaffolding, you can close it together, and then it is finished. And in the moment, we make a very, very big project with Anna Heringer. It is Campus St. Michael Forum Traunstein. It is really very, very big. It is 75 centimeter thick blocks. You see, this is all load buried. Here are the blocks. The ceiling is a concrete ceiling. And you see here we produce it in our manufacture factory. Here are the thick blocks, the joints where to fill up. The lintel inside, that is a light concrete lintel. We fill it in the production. And the front side here is a small iron joint for the window. And yeah, and then you bring the first block on site, really big blocks. Here is also a blitz. So this is for the electric goes through, has to go through. And then you have to fill up, and there is you have to set every wall construction, and you have to protect this with blanket for the rain until it comes then element there, the ceiling. And you see here the big blocks, there's and the joints. And now at least other interesting projects. It is also connected earth and wood construction for future, that the load buried is wood, and inside there is prefabricated elements. These are very small panels. It's only 7 centimeters. in blocks. You can fix it inside, make the joints retouching, and then you have really like earth construction, and you have a very good quality of climate, also climatization, water and temperature, and or you can make prefabricated in big blocks, very big structure, and this is a very rough material, and it is only 100% poor earth. That is, so you can feel it. You can feel the impact on human work. You can feel the compaction. It is like a geologic building process. Here, there is really big blocks. Here is a fireplace included. So this block is about 4 tons, but you can move it and set them. Or also we make a lot of stoves, heatings with this natural material. And what is interesting that the big structure, 75 centimeter thick wall or 7 centimeter, it is the same material. It is not more fine or like this. It is exactly the same material. It is only in another production situation, thinner shattering, more ramming like this, or you can also make a mochi bar in Vienna. It's prefabricated in Vorarlberg, fixed to there, and you see this here was the joint. This one part is transported, this part is transported. You can connect this, and it is really, yeah, it is a fantastic material. You can make some layers or some. Also, what is for me important that you produce this in a very high quality. The handcraft is very important, and or you can also build other structures with, so like this is a pavilion. What we have built together with ETH in Zurich with the students. This was a student's work design. It was a semester work, and the question was to build a pavilion with prefabricated elements. And I said to the students, they can use our factory for 14 days. In these 14 days, they can make all the structure and the arches. Then they was living 14 days in the factory and eating there, working there. And they have produced this themselves by hand. And then it was fixed on the side, open the last stone in there, and then you can remove the shattering, and the structure was finished. What we are, for me, is very important that we don't want to get more bigger company. What we want to scale the earth construction. We want to give the know-how transfer to the architects, to the clients, to the politic, to the government, everything therefore that we make research work also together with architects. That means that we have invited 3 architects, and they have make a case study for more family building house, and then we give them to teach them all the details, how they can use it. And what was interesting, that every 3 architect bureaus, companies, have complete different solution for the same issue, but with the same material. It shows me that the potential of architectural design in earth construction is really a lot. And we have to find a better solution. For that, we make also some publication, Haus Rauch or Gebaute Erde or the refined earth, upscaling earth. It is we want to share our knowledge that that it can really scale up the earth construction, that in future it should be normal to build with earth, and it should not be an exotic building system. It should be a very normal building system and sustainable. And for that, the most part is the worker and the people who have the handcraft. I use a lot of machinery, but the handcraft is always not the important part, because the quality of the handcraft is the education of the people. And in our production, we use a lot of technical, but there is also now 60% of the costs are personal costs. So, and if we would not use so much technical or Robertas or like this, we would not have less work. We would, a lot of building, we would never build it because it would be too expensive, because too much human work. And in our industry country, the human work is very expensive. And so this want to stop my my lecture today. There is a placard in Switzerland from Basler Kantonalbank. There they've asked, and how does your dream home look? And he said, living with my family in a clay house. So it is really a Paradigmawechsel, because the earth construction until now had no lobby and they had no image. The image of the earth house is very poor, but we have to change this image immediately. And so it is also important that we in Europe or in the industry country are building with earth construction in a very high quality size, that the image go back to other countries. And I know in the moment 1/3 population of the earth are living in earth construction. And my dream for 2050 is that not 1/3 would live in an earth house. So 50% of the people of the world would living in an earth house. And if we use with prefabrication, we can use the earth construction also in the urban towns or like this. Okay, thank you very much.